what we've got left today, oops, a little bit over, try a little bit more, there you go. Of course, if I start talking, people will arrive, but that's fine. We're going to look at solving linear differential equations. The only difference is that they're going to be a boundary condition. So this piece of information here will allow us to get the value of plus c. And so the first part, hopefully, is old hat. You've seen it before, you know the technique. But we have to do that bit. And we're going to end up with y equals some ugly function plus c. And then what we do is we use this piece of information to find out who c is. So let's start with this one. Is this one ready to be used as a linear differential equation? Is this the right shape? No, okay. So let's fix it. What do you need to do to fix it then?
Divide by 2x.
And if you do that, you'll get this. I'm going to call this fella that. And if you, oops, can't even count. If you divide this by 2x, you get the number 3. So I'm just rewriting that again because it looks messy. Okay, and that's good. P of x is 1 over 2x, which I'm writing like that. And Q of x is just a number 3. Now, 1 over 2x can be written as a half times 1 over x. You okay with that? And there is a reason why I want you to write it in this rather clunky way. So that's step 1 done. The integrating factor is e to the integral of p of x, which is e to the integral of 1/2 1 over x dx, which gives me e to the half natural log of x. Do you see, by doing that, I can just get the integral a little bit nicer. Now, we got algebra all over the place in these questions, and there's logs all over these questions as well. That's a very common kind of thing that happens. What we're going to look at here is a better way to write 1/2 natural log of x. So how could you do that?
Could you bring it inside as a power of x?
You could. And if you did that, you'd have a half power, right? And haven't we done the e to the log thing in a lot of questions? So hopefully it's pretty straightforward that the integrating factor is actually not that bad. It's just x to the half power. Or if you prefer, the square root of x. So now we can move on to solve it. Well, it's 1 over the integrating factor, the integral of this guy, qx, plus a c. So 1 over x to the half, the integral of x to the half times 3 right, to save a little bit of time here, that's basically 3 lots of x to the half. I don't want to write that line. So add 1 to the power. And divide by 3/2 is like multiplying by 2/3. 2/3 times 3 gets you 2. And I am going to take this answer and I'm going to multiply everything inside the brackets by -1/2. Are you comfortable about 1 over gets you a -1/2 power? if you multiply this guy and this guy together, reduce this by a half, you get 2x to the 1, which is 2x. And this fella, not so pretty, but you get that. Now, still on the style point theme, you get that. Still on the style point theme, you get that. And I checked this particular question before the class started, and this is the answer that they have in their answer grid. Well, it's going to have a number there, but that's the answer. So it looks like they were expecting this version. Now, does that mean that they might accept that one? I don't know. Will they accept that one? I don't know. They might even accept that one, right? Has anybody done any questions from this section and they've said to me, yeah, I tried all sorts of versions and everything was fine, or no, you had to be quite precise, it only took one? Has anybody experienced that yet? So I guess that could mean maybe you haven't done the questions, right? So I guess you'll find that out later, right? I'm just putting that warning out there that you may have the right answer, but WebAssign may not recognize it as the right answer. Because technically speaking, isn't that the same as this, for instance? Now, normally that would be the finish, because when you get to here, you have found what's called the general solution to the differential equation. Done. Well, normally we're done. But here, we're being given a boundary condition, which means that when x is 4, y is 19. So I'm going to put 19 in here, equals 2 lots of x, which is 4, plus c over the square root of 4. C over 2 is just another way of saying a half c. So 11 is a half c. So doubling both sides gives us c. And now we have the value of c. And that's the particular solution to the differential equation. And we are done. So what you're going to do is the same as yesterday to get this bit. And then you're going to use an extra piece of information that allows us to get C. And the only thing that appears in your homework is the final answer. They don't even ask you for this. They only ask you for the final result. So you could be doing the question 90% correct, and then you miss a +2 and you call it a -2, or you do something a little bit out, and that's what happens. Are we okay with this process for this particular question? Ready to move on? Okay. There's not that much to do, so we might even finish early today, because I'm just going to do as many situations as I think we need to on the added part of finding the plus C, right? Using boundary condition to find the plus C. So no particular reason this is 13. Got this guy. Got this guy. We've got this guy. And at least in my version of 13, the boundary condition has a 2. That's all. Tackle it the way I would tackle all these questions. I'd have a look at it and I'd say, is that the right shape? Is it good to go as far as linear differential equation should be written? And looks good to me, right? Derivative on its own, something with a v and something left over. in this question then, it's not going to be P of X or Q of X, it's just going to be called P of T, Q of T. So it really isn't the V like a Y and the T like an X, right? So it's just a variable change. This piece here, including the negative, and all of this, that looks a bit worried, doesn't it? 5t to the 4 e to the t squared. You can imagine later on that might cause lots of problems, right? So we keep our fingers crossed that something good comes out of this. Step 1 done. The integrating factor. That's going to be e to the integral of negative 2t. That's add 1 to the power divided by the new power. Not the nicest looking integrating factor, but actually I think it's going to turn out well. So we should be able to, that's basically step 2 done now. We should be able to solve, it's not going to be y equals, it's going to be called v equals. And it's going to be 1 over the integrating factor, the integral of I q, and a big plus c. So it's going to be 1 over e to the negative t squared, the integral of e to the negative t squared times 5t to the 4 e to the positive t squared. And something really, really nice happens algebraically. See, when you combine those two by multiplying, don't you basically just get 1? They cancel each other out. So how do you think I'm going to rewrite 1 over e to the negative t squared? Style points now. I'm going to make it look prettier.
E to the t squared.
Agreed. And this fella is now the integral of that fella. And that guy, add 1 to the power, divide by the new power. And here is the general solution to this differential equation. So the only function in the universe that has the property that its derivative, take away 2 times the original function, it equals that. So it's unique, with the exception of an arbitrary c, right? C could be any choice. So we now move on to our final stage. You're telling me that when t equals 0, v equals 2. So I have this guy. And when I make t equals 0, v equals 2, so 2 goes there. It's nothing to the power of 5, e to the power of nothing, plus c times e to the power of nothing. That is gone. That's 1. Yeah, that wasn't too hard. C is 2. And so we're finished. It's t to the 5, e to the t squared, plus 2 lots of e to the t squared. And that's the particular solution to a differential equation. Any questions about that one, or did it have a kind of flow to it that's kind of reasonably similar to ones we've done in the past? Let Megan take a picture of it. It really doesn't matter where I go, they're all ugly. Let's do 15. X squared y dashed plus 2x y is the natural log of x, and y of 1 equals 4. Okay, we know it's a linear differential equation because all of them are, but it's definitely not usable right now. Would you agree there's a problem? Now, if I divide everybody by x squared, that's what we got. Doesn't look too promising, but we know from past questions that it tends to work out well in the end, so we trust the math. We'll see where it leads. Step 1 done. P of x is this guy, and Q of x is that guy. The integrating factor is that guy, which is the integral of 2 over x, which is 2 natural log of x. Something kind of similar to that happened at the beginning of today. I think it was a half log x, if my memory serves me. And didn't we fix it the same way? So 2 log x becomes the log of x squared. And then we can do that. Because we really do want the integrating factor to be as pretty as possible, right? We want to give it a lot of style points, right? We want it to win the competition. And that's pretty elegant, isn't it? It's nice and clean and tidy.
So if we weren't to do that, would we just end up with ln of x?
If you went to do that,
If we don't use the log rule, yeah.
if you didn't use the log rule, I guess your integrating factor would be e to the natural log of x squared. I don't think I want to integrate that.
I meant before you did that. Line up where it's e to the 2 natural log of x. Could you just take one of the natural logs and then still just call it natural log of x?
Could you take one of the natural logs, call it natural log of x? Try and think what you're doing here. Are you thinking about splitting it like that? Because if you are, you're not allowed
because
to.
you have 2 lots of the natural log of x, and the e would cancel one of them.
Well, technically speaking, both of them have the same e.
I see what you're saying.
And that would just get you a kind of long way to get x squared again. So yeah, you're not allowed to say, forget about that and just say cancel this and have x, and then, you know, the 2 that's left over, I guess, just makes it 2x or e squared x or some other combination. None of those are algebraically correct, so they don't work. So we are ready for solution. One of those, followed by this integral, I'd say. Well, 1 over x squared. The integral of x squared times the natural log of x over x squared dx. You see what happens when you trust the math? You can almost, sometimes anyway, can you almost predict what's going to happen, because you kind of say, oh, look, that thing there better not be alive at the end, because if that e, the sine squared, is still there, I'm in trouble, right? So you kind of know that some's going to go. And when I look at this question, I'm thinking, I hope that x squared is gone, or at least I hope the log's gone, right? I want one of the two to disappear on me. And in this case, it was the x squareds. Okay, the integral of log x.
X times the log of x minus x.
If you do that, guy, often enough, won't you just memorize them? Just like 1 over 1 plus x squared. If you couldn't memorize it, or you can't find it because you didn't write it down, that's the guy we're trying to find, right? It's an integration by parts. What you do is you pretend it's 1 times the log of x. Who would you choose for your f in this integration by parts? The 1 or the log x?
The log?
Correct. And you have f big G, take away f dash big G dx. The reason you choose f here is that there's lots of rules about how you pick f, how you pick g, just like, isn't there lots of u sub rules? But there's always special exceptions, you know, special cases. Well, one of the rules for choosing f and g is if you can't integrate it, make it f. Right. We're assuming I can't integrate log x, so that's why I picked that as f. So let's see what we get. That guy gets left alone, and you integrate 1, which gives you an x, so stick it at the front. Take away, if you differentiate that, you get 1 over x. If you integrate 1, you get an x. So what we have is x log x, take away the integral of 1, x log x, take away x, and that's where it came from, plus a big ugly c. Now, style points. I'm not sure I can convince you this time that this is an improvement, but we're going to try it anyway. I'm going to call that x to the negative 2 so I can distribute it. If you multiply this by this, you get x to negative 1 log x. This by this, you get x to negative 1. And this by this, you get cx to negative 2. I'm then going to call this guy log x over x, take away 1 over x, plus cx squared. And that would be one of the many different versions of the correct answer. I'm not that convinced that this is particularly pretty, because I don't think it is. If you want to see another version, wouldn't that be algebraically the same thing? I think that one, if they were having a pretty competition, that one would win in my mind. I have no idea. Well, we're going to find out what C is in a minute, but I have no idea what WebAssign's going to do there. So have fun finding out which version it likes. So we've got our solution. Which one do you want me to work on? Do you want me to do find the C when it's written this way, or find the C when it's written that way? Because you've got to find the C, right?
The second one.
Okay, so we'll take this one. The boundary condition was that. So when x is 1, y is 4. So I'm going to put a 4 there. It's going to be 1 times the log of 1. Take away 1, add c, all over 1 squared. Right, 1 squared is 1, so divided by 1 doesn't do anything. the log of 1 is 0, so I end up with just that, and that gets me 5. So we have x log x, take away an x, plus 5 over x squared. Or log x over x, take away 1 over x, plus 5 over x squared. These are totally the same thing. I don't know if it's dawned on you. Have you noticed that as you do more and more math, questions take more and more lines to get the answer? This particular one depends on how much you actually write. It's about 16 lines. I think we've probably done some questions, if you count the bit at the side, we've done questions that had 20 lines. So when you're doing questions that involve lots of steps, because each line is basically a step, you have to have very clear process in your head. I'm going to do this to get that, and then once I get that, I'm then going to use it to get this, and once I've got that, I'm finally going to get this, and then maybe after that, now I'm going to find the C. Do you see there's a kind of A, B, C, D, E, F, all the way down the chain? And if you don't have a clear thought process of, this is where I am, but I know how to get to the answer, right? This is the roadmap of how to do it. Then these questions can just kind of overwhelm you by just their size. So I tend to do them as, you know, A to B, and then B to C, and then C to D, like step 1, step 2, step 3 kind of thing. And for me anyway, that kind of helps to manage the fact that these questions can be huge, right, just big. Hopefully what has happened is that you've stopped noticing how big they are. They're just, that's what you do, and you just do it. Hopefully you're at that point in your kind of math life. Just curious, does anybody, have you noticed the fact that the questions are getting bigger?
Yes.
Right. Is it something that you're comfortable with, or at least you can cope? A few nods. Right. Math has got one thing in its favour against, say, English. Isn't there only typically one right answer, so you know when you're right? You know, okay, there's a couple of flavours of the right answer, but it's still the same answer, right? They're all the same as each other. And very often, isn't there a process that gets you to that? Right? If somebody went and said to you, write an English article, isn't there all sorts of ways you can tackle that, and all sorts of qualities to how good the finished product was? Right. Now, a lot of people love English because it's variety and vagueness. And one of the things I love about math is the certainty of it all. I know that the solution we just did is going to be correct 2 million years from now. Because mathematics is pure, right? It just tells you the truth. Now, maybe the truth is quite limited. You know, it tells you the solution to an equation, but it's still true. It's still the answer, no matter how far in the future you decide to travel. I want to do just one more question here. A lot of the questions I've been doing lately seem to be the same, and I want to try and see if I can figure something that isn't quite the same. So for my last question today, we're going to do 18. Would it like 18? I kind of like this question. I could have picked one of the others, but this one has got, I think, as many things that need to be fixed as possible. So it's kind of like it's got everything in it. And the first thing it's got in it is that it ain't ready to be used as a linear differential equation. And do you see that y is in the wrong place, and isn't this x not meant to be there? Just a minute, to mention a couple of things. So I'm going to just take it slowly. And divide by x. So I kind of liked the question because I had a couple of manipulations to do even before we're started. The next step isn't really going to be that messy. So let's find the fella. The integrating factor is e to the integral of px dx, which is e to the integral of that guy, which is e to the negative log x. Okay, we've done 2 log x, and that was log x squared. We've done a half log x, and that ended up being the log of x to the half. This is -1 log x. What's that going to become?
1 over x.
Correct. And 1 over x is totally fine. I'm just going to call it x to -1, but if you wrote 1 over x, that's totally cool. Which means that we get that guy. Now, I could call him 1 over x, and that'd be fine if you wanted to do it here. I'm just going to leave it as -1 again. And I would say we're finished. So we can now do a solution. Okay, we got some tidying off to do. We got some style point things to do. Do you think, if you think about it, isn't there a better way to write 1 over x to -1? You agree? It's just x. I guess you could say x to the 1, but we never write 1, don't we? You know, like 1 over x to -2 would be x squared, for example. Won't x to the -1 times an x combine really nicely? In fact, don't they just cancel each other out?
What happened to your 7?
I had a 7? Oh! What happened to my 7x squared? Right. So, well caught. What about x to the -1 times 7x squared? Doesn't that reduce a little bit?
You divided by x, so it would just be 7x sine x.
Hey, if I'm going to finish, I should finish my usual thing of making mistakes. So you're right, it is 7x. So when you said, what about the 7 I scanned up here, when I should have scanned here. The x's still cancel. Which means that it might have looked kind of ugly, but it's actually quite simple now. And if you integrate a sine, you get a negative cosine. And that would be our general solution. And if that's all they wanted, we would be finished. Well, I'd probably multiply it out, but we can do that in a minute. So y is equal to negative 7x cosine x's plus cx. And we're going to use the boundary condition. Then when x is pi, y is 0. So you get a 0 here. A negative 7 pi, no, cosine of pi, yep, plus c times pi. Okay, cosine of pi is a nice number, isn't it? Can you remember what its value is?
-1.
Yeah, -1. Which means 7 pi plus c pi equals 0. Now the goal here is to find c. So what should I do to both sides to get closer to that place?
Subtract 7 pi
Agreed.
divided by pi.
Also agreed. And so we can now say negative 7x cosine x plus cx becomes minus 7x. And I'm looking at the solution, at least my solution, and that's correct. So do you feel comfortable if you were given a differential equation and on top of that a boundary condition that you could solve to get the general and then find the missing c to finish the question? Are there any more questions? Then let me just remind you what's happening in the next few days. Tomorrow we're reviewing for the test and the final. It's pre-open-ended, so whatever you ask me, that's what we'll go over. On Sunday, the 6th, all homework, that means up to the end of this, needs to be done. That's your drop dead date. On the Monday, you'll be given your test, test 4. You do not need to go to test 4, sorry, test 5. So it's test 5 on Monday. You don't need to turn up to test 5 if your first 4 tests are so good that you know you're probably not going to improve your grade. If you have a bad test, you really need to turn up, so do. And I would count the best ones, best 4 anyway. So you can never hurt your grade by turning up. And then I won't see you after Monday until the day of our final. And I believe our final is on Thursday. And it's from 10 till 1. Does that sound about right? That's what I've got when I looked it up. If
I had a
that,
question.
yes.
Do you plan on doing a practice final, or is it entirely up to us?
There's no practice finals. All you've got to work with is WebAssign and every test you've ever done and homework. So I think I've opened up all the homework again. Have I done that so you can actually go back and see old homework? Pretty sure you can do it. If I've not, I'll try and make sure I do that. But that's what you're going to work on. Just think of the final as a very big test. It will be on WebAssign. It will just look just like WebAssign stuff. It'll be WebAssign questions with different numbers. So it shouldn't be any shocks. The test is the final, I should say, is designed to last 2 hours. I just give you 3 hours to make sure you're safe, right? So you're not rushed. If the time slot doesn't work, it might interfere with your physics exam or something, then you email me and I will arrange a different time slot for you to do the final, okay?